Assalamualaikum everyone. Today's episode on elastic collision in two dimensions focuses on calculating the speed of a particle and the angle of deflection after colliding elastically with an identical particle. Just before the collision, one particle is moving at a certain speed along the positive x-axis and the other particle is moving at a faster speed along the positive y-axis. To find out how we analyze this problem, just stick around, watch and learn. The question is, a particle A moving 2.0 meters per second in the positive x direction collides with an identical particle B moving 2.5 meters per second in the positive y direction. Find the speed and angle of deflection of particle B if particle A was deflected at an angle 30 degrees above the negative x direction with a speed of 3.0 meters per second. First thing first, let us identify the given data. We have the velocity of particle A before the collision, v sub A equals 2.0 meters per second, directed to the positive x-axis. We also have the velocity of particle B before the collision, v sub B equal to 2.5 meters per second, directed to the positive y-axis. And we are also given the velocity of particle A after the collision, v sub A prime equal to 3.0 meters per second, directed 30 degrees above the negative x-axis. And our target variables are the speed of the particle B after the collision, denoted by v sub B prime, as well as the angle of deflection of particle B, denoted by the angle theta. Just before the collision, the momentum of particle A along the x-axis is expressed as px equals positive 2.0 meters per second times its mass, small letter m. Particle B has zero initial momentum along the x-axis, but it has an initial momentum along the y-axis, expressed as p sub y equal to positive 2.5 meters per second times its mass, small letter m. Okay? So, both particles have the same mass because they are identical particles. Now, just after the collision, particle A has a momentum denoted by P prime. Its magnitude, alright, is equal to 3.0 meters per second times its mass, small letter m, and its direction, as shown in the diagram, it is directed 30 degrees above the negative x-axis. While particle B, alright, has a final momentum denoted by P prime sub B equal to the product of its unknown speed, all right, b sub prime b multiplied by its mass, small letter m. And its direction, as shown in this diagram, is denoted or described by the angle theta. All right. So both the speed of particle B after collision and the angle of deflection theta are our target variables. Applying the law of conservation of momentum along the x-axis, that is, the initial total momentum along the x, or label here as p sub xt, is just equal, all right, to the total momentum after collision, total momentum along the x, labeled as p sub x prime t. And only particle A has an inertial momentum along the x, which is 2.0 meters per second times its mass, small letter m. Particle B has no inertial x component of its momentum, so that's 0. And on the right side of this equation, we have the momentum after collision for particle A along the x, and that is its mass, small letter m, multiplied by its x component of velocity, which is negative 3.0 meter per second, cosine of the angle 30 degrees, plus the total momentum after collision of particle B, all right, which is its mass, small letter m, multiplied by b sub b prime, which represents the final speed of particle B after collision, but that is to be multiplied by the cosine of the angle theta, right? So, since the mass, small letter m, can be cancelled out, and we can simplify the equation to just 2.0, all right, disregarding the units first, so that is equal to negative 3.0 times the cosine value of 30 degrees in two significant figures, which is 0.87, and then plus b sub b prime and multiplied by cosine of the angle theta. All right, so we will come up with a formula, b sub b prime multiplied by cosine theta equated to 4.6, and we label this as our equation number 1. We also apply the law of momentum conservation for the y components of the momenta of particles A and B. Only particle B has an initial y component of momentum, which we simply express as 2.5 meters per second, because the constant mass m has already been cancelled out. And this is equated to the y component of particle A's final momentum expressed as 3.0 meters per second times the sine value of 30 degrees. Then we add the y component of the final momentum of particle B, which is expressed as b sub b prime times the sine of the angle theta. And simplifying this, we will get b sub b prime times sine theta being equal to 1.0. And we label this as our equation number 2. Alright? Earlier, we have equation number 1. B sub b prime times cosine theta also equal to 4.6. Alright? So when we divide equation 2 by equation number 1, alright, we will be getting this formula for finding the angle theta. That is, the angle theta is just equal to the arctangent of the ratio 1.0 divided by 4.6 or 0.217. So using your scientific calculator, we have the value of the angle theta equal to 12 degrees. This is the angle of deflection, alright, of particle B just after the collision. And as shown in the drawing, that angle 12 degrees is defined as the angle above the positive x-axis. Knowing the angle of deflection, we can now use equation number 2 to find the magnitude of b sub b prime, which is all right, 1.0 divided by the sine of 12 degrees. Okay? Hence, we will have the value of the speed of particle B just after the collision, which is 4.8 meters per second. Alright? Or this is the magnitude of the final velocity of particle B. Its direction is, as mentioned earlier, the direction is defined by the angle theta, which we have already calculated to be 12 degrees above the positive x-axis. So we say that the final velocity of particle B is 4.8 meters per second, directed 12 degrees above the positive x-axis. Now, we can check the answers, all right, by computing the initial and final total x components and y components of the momenta, right? So, in just a short while, we're going to prove that piece of xt is equal to piece of xt prime. This is the equation for the total momentum before the collision along the x component. Likewise, the total momentum and final momentum along the y-axis, piece of yt being equal to piece of yt prime, okay, also has to be checked, or we have to prove that these two equations are indeed satisfied. For the x components, we have particle A's velocity, alright, which is 2.0 meters per second. For the initial momentum with the mass already cancelled out. And particle B has zero initial x component. So this is equated to the final x component of the momentum of particle A, which is negative 3.0 times cosine of the angle 30 degrees plus that of particle B, which is 4.8 meters per second times the cosine of 12 degrees. Simplifying, we have, all right, 2.0 equals negative 2.6, all right? plus 4.6. So negative 2.6 is just the result of multiplying negative 3.0 by cosine 30 degrees, while 4.6 is the result of multiplying 4.8 times the cosine of 12 degrees. So we will see that pxt is indeed equal to pxt prime. Okay? So here we say therefore that the conservation of momentum is satisfied for the x component of the momenta of the two particles. Similarly, we do the same checking for the y components. P sub yt is also equal to 2.5, all right? And P sub yt prime is 3.0 times the sine of the angle 30 degrees plus 4.8 times sine of the angle 12 degrees. And simplifying, we see that the initial total y component of the momentum, which is 2.5, is also equal to the final total y component of the momentum or momenta for the two particles. All right? So, the law of conservation of momentum is also satisfied as far as the y components of the momenta of the two particles are concerned. Before I end, let me give you this challenge question. Show that this collision described in the problem, which is a two-dimensional collision, is not a perfectly elastic collision. All right? If you know the answer, drop it in the comments section. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.